Today we're going to talk about inverses, inverse relations and functions. This is 6.7. Finding an inverse of a function is what we're going to do in this section, and determining if two functions are inverses and graphing the inverses. All right, so an inverse of a function. Two functions are said to be inverses of each other if their compositions result in the identity function. In other words, they both have to equal x. So if you take the g function and put it into the f and solve it, you'll get x. And the same is true if you put the f function in the g and solve it, you'll get x. An inverse of a function has the domain and range reversed from the original function. And then inverse functions undo each other. And the symbol that we're going to use for inverse, you can read it, is f to the negative 1, okay, which is read the inverse of f. All right, to find an inverse of a function, you have three different choices depending on what they give you. If you have a set of points, all you have to do is switch the x and y coordinates. For example, the ordered pair of negative 2, 4, the inverse is 4, negative 2. Don't change the signs, you just change the order. So x becomes y and y becomes x. All right, if you have an equation, you're going to switch the x and y and solve for y. So for example, y is equal to x plus 2. I'm writing it up here, it's also down here. You're going to change the y and it's going to become x. You're going to change the x and it's going to become y, and then you're going to solve for y. So you're going to subtract 2, so that's going to become x minus 2 equals y. This is the inverse of this. Okay? All right, so we will be doing that. That's very simple to do. We'll do more problems together. And if you have a graph, you're going to do the same thing as an equation. You're going to then graph, or you can make ordered pairs and then switch your x and y's. So you can graph your equation, find your points if you want to, and then switch them and then graph those points and make your inverse, okay? Or you can take the equation, switch x and y out, solve for y, and graph the inverse. Either way will work. All right. So those are inverses. Let me show you an inverse in function and how you can tell if it is inverses of each other. You have, oops, sorry, let's change color. You have f of x is equal to, let's see, x plus 2. And so we want to know if these are inverses. Let's see, that's going to be, making this up as we go. X minus 2. Let's try that. What you want to do, this is g of x. We'll call this g of x. We want to know if it is a function, an inverse. We'll take the g of x and put it into the f of x. So I will take this and put it in here. So that's going to be x minus 2 plus 2. Okay, that's the f of x. Okay, then we're going to do the opposite. We're going to take this one and put it there. So that one's going to be x plus 2 minus 2. Okay? When you solve these problems, you're going to see negative 2 plus 2, well, that just leaves x. 2 minus 2 just leaves x. So that means that these are inverses of each other. So if they give you two functions, you're going to take one and plug it in the other and then get an answer. It should be x if it's a function, and the other one goes in the other. So you just put one into one and one into the other. See which one makes x. They both have to equal x in order to be inverses. Okay, that's one way to check. All right, if you have ordered pairs, like 2, 3, negative 2, 0, 1, 0. Okay, if you want to find the inverse of those ordered pairs, you simply just switch around your x and y coordinates. So this would be 3, 2. This would be 0, negative 2. This would be 0, 1. Okay? So this is the inverse. This is the original. Okay? Then they will ask you questions such as, is the inverse a function? Okay? How do we know if something's a function? Okay? If the domain does not repeat, then it's a function. Okay, so let's look at our domain. Our domains are our x values. So right here, our x's are right here in the front. We have 3, 0, and 0. So our inverse is not a function because we had 2 zeros. It's still an inverse. It's just not a function, right? When you look at our original, it was a function because it was 2, negative 2, and 1. That is a function, but its inverse can not be a function. Now, if you were graphing, change this to a grid so we can do this. Can't find it. There you go. Sorry. All right, so if I have a graph, all right, and say I have a function. We know that parabolas are functions, okay, because they pass the vertical line test, okay. But if you want to check to see from a graph if you have your inverse will be a function, if you do the horizontal line test and it touches twice, then that means that the inverse will not be a function. You still have an inverse, but it's just not going to be a function because it's going to be turned sideways. We know that x squared is a function. Now, the inverse we found out the other day would be a square root because square roots undo squares. So this will be the inverse, and square roots start at the origin or wherever they're shifted and go this way. Okay, so that is why it will not be a function. So you can see physically that it will be the original is a function, but the inverse won't be. And you can test before you even draw the inverse by drawing a horizontal line through your original, and if it touches twice horizontally, then the inverse will not be a function. And that's all I guess we need on this section, and if you have any questions, come see me. Bye.